Hi guys, we are continuing our Hyperledger fabric. So now we are going to discuss on Chaincode and what is private data collection. Okay, so as I said before, I am just following the Hyperledger fabric org document to do this. So first, what is a Chaincode? So in our previous video, we were discussing about smart contract, right? What smart contract can do. Now we are going to be more specific on Hyperledger fabric product and going to understand the chain code because chain code is kind of development activity in blockchain, and any blockchain developer definitely working will be working on the development of chain code. So if you see here, basically on Hyperledger Fabric, I mean to say it's a chain code is a program, okay, written in Go, Node.js or Java that implement the prescribed interface, okay. So this chain code will needs a programming skill of Go, Node.js or Java, but it's not complicated to do. You will see in the how we are going to write our smart contract part, which is nothing but chain code. I will be referring to chain code going forward, which is nothing but smart contract in Hyperledger Fabric. Okay, where this chain code will run. Okay, this chain code will run in the Docker container, isolated from inducing peer process. Okay, so it will run in the Docker container. It's a piece of code, and Chaincode initialize and manages the ledger state through transaction and submit the application. Now Chaincode will work as an interface between your ledger and your application. Okay, your application will try to put the transaction via Chaincode, and then ledger will read. So it basically Chaincode manages and initialize the transaction submitted by your application, and you can think without chain code, if you want to make your application to interact with your ledger, it is difficult because it's not a database where administrator gives you some JDBC ODBC connection or IP address. Okay, then chain code is typically handles the business logic. We know that to the members in the network, it may consider as a smart contract. It's a smart contract. Okay, chain code not only an interface between the application and the ledger. While while it is while it is interface between application and ledger, it also has the business logic what the application can do with the ledger. The application, if want to see the data, then it should be in chain code. Application want to edit the block or the data, it should be defined in the smart contract. So ledger updates created by chain code or scope executely the chain code and can't be accessed directly by another chain code. That means the ledger is having one chain code, cannot be accessed by another chain code. So one ledger will be accessed by one chain code. Okay, one ledger cannot have two chain codes. Okay, so in our previous part two, you could have seen the blockchain network. We had a peer node two with two ledgers and two chain codes. Okay, one ledger with two chain code, it doesn't match. So that is what they are trying to explain. If you have one ledger, you should have one chain code to access your ledger. But if you have one ledger and two chain code, only one chain code will work. Another chain code doesn't work. However, within the same network, the appropriate permission, the chain code may invoke another chain code to access its state. So one chain code can access another chain code, not the ledger directly, but no appropriate, because these two are programs, right? Basically, programmers knows how they can interact two programs together with the APIs, and lot of application interfaces are available, so that can be done. So I hope this gives you the fair idea what is chain code is. You can consider chain code is a program written in Go language, Node.js or Java. It will be run in the Docker container environment. It is used to manage the transaction between from the applications to the ledger. Basically chain code handles our business logic between the members in the blockchain network. Okay, now, and we need to install and define the chain code as a blockchain developer. Now our real hands-on is coming. We understand the concept. Okay, we understand that. Now when we go to the implementation stage, we need to understand. So fabric chain code, Hyperledger fabric chain code lifecycle requires the organizations agree to the parameter that define the chain code, such as name, version, and chain code endorsement policy. Okay, we will talk about the endorsement policy in the later one. Right now, we will understand the chain code. So now, chain code is our business logic, right? Now we talk about different organizations in our previous session, like R1, R2, R3. If you see the part two, when we write the chain code, how the chain code should be, what is the name of the chain code, how what version we can maintain, what version has been correctly deployed into our network. So it's a one network, right? If someone see already went through my part 2 video, they might understand the blockchain network and visualize it is one single network with multiple organizations. So multiple organizations should agree with certain defined parameters how the chain code should be developed. Okay, so this is the first thing. Then channel members can agree using the following four steps. Okay, not every organization on a channel needs to complete each step, so it's not mandatory, but members can agree with this thing. So package the chain code. Okay, so this step can be completed by one organization or by each organization. So one organization can develop and package the code, right? What is the business logic? I know the business logic when I discuss with my organization, and I am a developer. My organization is a developer, they can package the chain code with the steps. Now we are in the same blockchain network. We need to install this chain code on each and every peer. Like first, I have to install in my peer. Like every organization will use the chain code to endorse a transaction or query the ledger. Ledger needs to complete these steps, right? If they want to access the ledger endorsement, you can consider validation right now. So if they want to kind of approve, endorse, you can consider approve or approve the transaction, or they want to query the transaction. Every organization needs to install this chain code on their peers. So in our previous blockchain thing, we have also see peer node 1, 2, 3, 4 peer nodes for 4 organization. Each organization will have one peer node, and this chain code which we packaged needs to be installed there. Okay, now approve the chain code definition for your organization. So every organization that will use the chain code needs to complete this step. The chain code definition needs to be approved by the sufficient members of the organization to satisfy channel lifecycle endorsement policy, a majority by default, before the chain code can be started on the channel. Okay, now we are deploying a new chain code. So say when you deploy a new chain code, you set up some new policies and rules to the business network, right? So uh, it needs the approval to get reflect in the network. Mostly this approval may be based on majority. If you have 5 people, if and 3 people approves it, then it considers a majority, and it starts in your channel. So right now you can understand, right? So it's decentralization, and there's no central party to enforce it. Everything will comes in the voting process. In the voting process, if majority is approved, then this agreement, basically your business rules and agreement is approved now. And this because most of the people agrees to this rule. Say for example, I have a business policy that I need to pay a penalty if I was not delivering the product by 5 working days. Then most of the people agrees it. Then that became the rule. Even the next two is trying to say no, but it is a voting process again. Then finally commit the chain code definition to the channel. So what is channel? We have seen in the previous part 2 video. It is a logical separation within the logical separation of organizations within the same blockchain network. You can go and look for detailed understanding of channel. So the commit transaction needs to be submitted by the one organization once required number of organizations on the channel have approved it. The submitter first collects the endorsement from enough peers of the organization. Endorsement means just but approval. So what happens? One person is committing this. We talked about committer node in the previous video as well. So commit the transaction, and now first transaction, it should be when a lot of people approves it, then this the first submitter node collects all the approval, and it says okay, this sign code is been approved by everyone, right? If no one is approving, endorsing, then it is not it's not going to be part of this network. So we understand what is chain code and what is the process when we work on the chain code. Basically, this happens between the organizations, how they want to package. and then they need to install into the each peers for the network to work. They want to do some transaction with the ledger, or they want to query the data. Chain code is required. Okay, then we going to see packaging one of the smart contract. If you see here, there is a organization one and peer one, organization one, peer two, organization two, peer one, and organization peer two. So one organization can have one or more peers. So this is the chain code package. They have labeled it MCC1, my chain code one. Okay, it's nothing but my chain code underscore one, and the same will also be here. So here we have given the example in the document, say Hyperledger sample, Chaincode tab or Go. Okay, they have type Go language label, and it's Hyperledger V1. So this is how they have this smart contract content. So the chain code, it's not one chain code, it's two chain codes separately for organization one and organization two. Both chain code use the same. That is why it's more good to insist on this label. Otherwise, if I am using my CC2 and you are using my CC, we are not in the same contract, or it is a different. So that is why package label is identify the name and version. So and also it is not necessary for all organizations to use the same package label. Okay, the underlying whatever is written in the rules should be same, but it's good practice to have the label and see our both organization is having the same smart contract. So that is the step one. And step two, if you see, we each peer needs, so in the organization level before we saw both the organization needs separate chain code. Similarly, each node needs to be deployed. Okay, so this is the node, a peer node, which is maybe the Linux server, which is Hyperledger Fabric is running on it. So but it is here the chain code need to be deployed and installed maybe. So here the chain code needs to be installed. In the node the chain code should be installed. So each and every node the chain code needs to be installed. Okay, it's a code. Now when the organization or peer node is there, the peer node needs this chain code needs to be installed in each and every machine. It's not like that you the two peers are on same organization, you can install in one and you can leave it in other. So when you install hyper chain code in each and every node, then only this all the nodes are in same no same rules or same sync or same network. If different chain code is there, then it, or if chain code is not there, then also you should consider chain code as a program needs to be deployed in each and every peer node. Maybe it cannot be same chain code or different chain code, that doesn't matter, but every peer need a chain code to get the data from the ledger. Okay, so basically same ledger this everyone is sharing. That is we are understand, but it's not a same means it's not a same node, it is a different node. Okay, so these things, if you need more clarity, just go to my part 2 and see the blockchain network, so you will get a fair idea what I am referring here as a peer node. Okay, now you can see approve the chain code. Now someone in the step 2 has installed the maybe is administrator of the peer node installed it. Now once we install, now chain code definition is my name is mycc version 1, end policy 2 of 2 sequence 1, package id is something hash. Okay, now chain code definition is, so because these two are my ledger, right? So and this I have deployed it. So the organization administrator now needs to approve the chain code definition for mycc for the organization. Okay, the chain code definition includes, now he needs to check for the name, and this organization check for the name, he check for the version, he check for the version, he check for the endorsement policy, he check for the endorsement policy. Since both the organization will use the same chain code and tell, they approve the definition. So my company is telling, okay, I'm going to deploy version 2, then I get the version 2, I verify it's a version 2 we're going to deploy, and now that once they approved this time code, one checking the time code definition, it is going to be active in the peer nodes. I hope this is clear, right? Then step 4 is commit the chain code definition to the channel. So now we are talking something about channel. As I said before, channel is a logical partitioning of your organizations within the network. You can go in detail in part 2 Hyperledger Fabric video. Okay. Now, once the organization 1 and 2 commits the chain code definition, install the chain code definition, they need to commit it to the channel which these two organizations are communicating. So then all transaction will come via no channel basically. So now channel does not include a package ID. That is the one thing you have to see, because channel is just a logical layer. It is not a physical server or physical layer. It's a logical layer within the network. So it doesn't need the package ID, but it needs to know the which chain code it needs to use. So it needs the name and the version and endorsement quality and sequential. So this we are committing to the channel which these organizations are belong to. Okay. Then Enoch, the first Enoch of Chaincode. Now everything is set up. Where the Enoch happens in the channel level. Okay. So once the channel is once you define channel, now Enoch means now the application start to invoke the from your ledger to the application. The communication happens. So just I have taken this here. After the chain code definition has been committed to the channel, the chain code container will launch on all of the peers where the chain code has been installed. Okay, now it will launch, allowing the channel members to start using the chain code. It will allow all the channel members to start using the chain code now. It take a few minutes for the chain code containers to start. Then chain code requires, so it is actually kind of downtime when you change the chain code. Your transaction, your ledger transaction is not going to happen. Maybe when you installing first time it doesn't matter. There is also upgradation of chain code, which I'm not focusing right now, but you can go and check into the Hyperledger Fabric link which I am provided below, which is also available in public. So first we will talk about no, how to deploy for the first time. So then the Enoch start with init function. Init is just to start the containers, and the chain code is now ready to accessible by your applications. Then this is the process of the chain code. Now I am going to talk about the new topic. If you have any doubt about chain code and process, so we are going to step into the implementation step. But right now, if you have any sort of doubts, just feel free to comment it. Okay. Because I can provide you the reference, and I can also try to answer your question over here, but we will see the hands-on going forward. Okay. Then what is the private data collection? Now it's very important. The collection, private data collection is combines of two things. One is of actual private data, and other one is hash of the data. Okay. The actual private data is nothing but sent peer to peer via gossip protocol to allow the organization to authorize it. This data stored in the private state database on the peer of authorization organization, which can be accessed from the chain code on this authorization peers. The order service is not involved here and does not see the private data. Note that because of gossip attribute the private data peer to authorization, it is not required to set anchor peer. Okay, we talked about anchor peer in the network blockchain network setup. It requires when we talk from one organization to the other organization. Here, what we are there is something called order node who receives the transaction and puts into the ledger. But there is something called private data collection where from the ledger, no, this data can be privately sent to the other ledger using the peer-to-peer protocol or gossip protocol from one organization to other organization. You can see one organization has this authorized peer, another organization doesn't have the authorized peer, but they both are in same channel and they are sharing it, sharing the data. Okay. Second thing is hash of the data. So, which is endorsed to order node. So, order who is the approver written on the ledgers for every peer on the channel. The hash serves as the evidence of the transaction and used for state validation and can be used for audit purpose. So, the hash is nothing but every block will have a hash K1. So, if you see the hash K1, right? So, hash K1. Actually, the private state doesn't have hash, it has K1 secret value. Okay. but when you comes with the hash, it is saying hash k1 hash secret value. So when the data is approved, now we get the transaction state using the this hash. We can able to see know all the transaction, and we can use it for audit purpose. Whereas in the private state, we cannot do it. So basically, there's two state, right? Channel state and the private state. We are discussing here a new concept called how to privately no send the data, do the transaction between one peer to another peer. This is also a concept from Hyperledger Fabric. Okay, so you need to understand that from one peer to another peer, we can able to send the data privately using a peer-to-peer gossip protocol. And there is it consists of two things. It consists of hash of the data and actual data. You can send the actual private data, or you can hash the private data. But if you hash the private data, it goes to the it goes to the ledger, and it has the evidence of the transaction. But if you are not sending the hash of the data, it doesn't have the evidence. Okay, you can go more detail into it. So when we can use collections and within a channel or separate channel. Okay, sorry for that missing a L in the channel. So we can have a separate channel for the transaction of two peers. We have discussed a lot in the blockchain network again. Okay, I don't want to take the time here to again explain. That is why I'm trying to tell it. I will try to provide the link in this in this thing also as a prerequisite. So use channels. When we use the channel, the entire transactional ledger must kept confidential within a set of organization that members of the channel. Yes, we have discussed this. If we have four organizations, and out of the two organizations need to be separated from other two, and these transactions to be entirely private, which these two are not aware, then we go for channel. But when we use collections, when transactional ledgers must be shared among the set of organization, but when only the subset of those organizations should have access to the sum of the data within the transaction. Additionally, since private data is dismissed peer-to-peer rather than via blocks, use private data collection when transaction data must be kept confidential from the ordering service node. So if you see some data between this organization needs to be private, and not all the data. Okay, not all the data, just some data needs to be private. Then we can share it with the peer-to-peer without we are skipping the ordering node. Ordering node will go and keep it as a block, right? So we are skipping that, and we are using the peer-to-peer process. So this depends on the use case. What kind of use case, what kind of requirement we are getting. We are going to talk more about the use cases and the requirements in the next coming videos. It will, I hope it will be quite interesting, and you are getting some knowledge on Hyperledger Fabric. It's good we complete our uh, complete the complete our knowledge in the theoretical, and then move forward to the practicals. So keep watching, and then if you like it, my videos, please like it. And if you like me to continue to do this stuff, please also subscribe. Thank you so much. Bye.